Hello, my name is Semavi Akin. I am responsible for system certification in KNX Association. Today, I'm going to talk about KNX IoT third-party API Server certification tests. I will start with test specification. Then we will have a look to the new version of EITT 4.4 and the new feature of EITT 4.4. Then I will show the test setup which I am using for certification, and finally I will explain all test steps. Latest KNX standard version is 3.0.0. All system specifications are located under volume 3. 3.10.4 contains IoT third-party API system specifications. In the same volume, you can also find all other IoT-related specifications like KNX Point API or KNX IoT Information Model. All test-related specifications are located in volume 8. 8.10.4 contains third-party API test specifications. First, we will have a look to the content of third-party API test specifications. In the first chapter, endpoints, all supported endpoints with related methods are shown. For example, if you look to 2.1, it shows that you can use get method with data point, this is the endpoint, to get a collection of all data point items of the installation. But also, if you look to 2.2, it shows that you can use again get method, but now data point with data point ID to get a single data point of the installation. This chapter explains what kind of checks are performed to be sure whether the test case is successful or not. For example, for all test cases, HTTP response and request headers are validated, if all required headers are contained or not. Similarly, every response is checked if an endpoint responds with the correct code. Also, every response is validated against JSON schemas. Also in semantic state validation, it's checked whether the semantic information in the JSON response is compatible with ETS project. This chapter, test categories. Actually, all test cases are divided into 4 categories. So, there are some static test cases. They are related to the project structure. There are some dynamic test cases, which are mostly related with runtime test and data points. There are some subscription test cases. These test cases are related with WebSockets and HTTP callback subscriptions. And of course, there are some security test cases, and these test cases are related with authorization. So, for all test categories, there are different test scenarios. There are positive tests, which are using valid parameters. There are negative tests, which are using negative parameters or invalid formats. And also there are some robustness tests that intentionally force the server. Finally, in chapter 5, you will find all test cases. It divided into many subcategories like function test, device tests, or location tests. For all test cases, there are explanation, description, and also an HTTP request example with expected result. There is also reference to the related test specification chapters. Let's talk about EITT, the KNX Interworking Test Tool. The main purpose of EITT is test compatibility of KNX devices against interworking and system requirements. But also EITT is used to create test documentation for test results and also for registration. So, where EITT is used, all accredited test labs are using EITT for certification tests. Also, member companies are using EITT in their development, test, and also production processes. For example, EITT is used for certification preparation in development departments. It's also used by manufacturer test labs for climate or some stress tests. And it's also used by production departments of manufacturers via using the automation API. Thanks to the automation API, EITT functions can be used in many programming environments like C#, Java, or Python. Current official EITT version which is used for certification is 4.3. However, a new EITT 4.4 is now available for evaluation purposes. As KNX Association, we are working to use a single test tool for all KNX applications and support all new technologies by this tool. For this purpose, we have developed EITT 4.4, which has many new features, and it's also very easy to adopt new technologies. If we generally check the differences between two versions, EITT 4.3 is using its own file format CTL, but EITT 4.4 is XML based and using a new file extension EITT Prosh. EITT 4.3 only supports template updates, automatically template updates, but in EITT 4.4 all software can be updated automatically. After that general comparison, I would like to share some of the most important features of EITT 4.4. First one is starting telegram sequence from another sequence. In EITT 4.4, it's possible to call another telegram sequence by using this command and telegram sequence name. EITT will suspend running of the main sequence, then call sequence will be run, and EITT will continue to run the main sequence. In the trace buffer, these main sequence and call sequence are marked with different colors. Another feature is running parallel sequences. It's also possible to start the parallel execution of other telegram sequences by using this command and telegram name. In this case, main sequence will not be suspended. Main sequence will continue to run, and also at the same time parallel sequence will be started. By default, this parallel sequence will be run once, but with the optional parameter, you can do it unlimited, or you can select a finite number. And also with this command, this parallel running sequence will be stopped. The next feature is test sequence compare function based on templates. EITT 4.4 allows to compare Telegram sequences that were created from different versions of same conformance test templates. This left side test sequence is generated via management test Telegram version 10, and that right side test sequence is generated via management test Telegram version 13. With this new feature, you can compare these two test sequences. As you see, new added telegrams in new sequence will be marked with green. Deleted telegrams will be marked with red in the old sequence, and also modified telegrams will be marked with orange. Next important feature is conformance test profiles. With EITT 4.4, the user is able to create conformance test sequence depending on conformance test profile. A conformance test profile determines which test case must be executed and which test cases are optional or must not be executed. The conformance test template can be selected from the combo box, from here in the toolbar, and of course it's still possible to select no profile. In this case, all test sequences will be created. In current EITT 4.3, KNX conformance datasheet variables are only valid when EITT is working. If you close EITT, then all variables are deleted. But new version of EITT 4.4 supports load variables from file and save variables to file. So it means when you create your datasheet, you can export the file. This is an XML-based file, and when you want to create new test sequences, you can import this file, and then automatically all datasheet will be filled. Actually, the most important features with EITT 4.4 is supporting KNX IoT. EITT 4.4 provides a new conformance test templates all together with a set of new telegram types. In EITT 4.4, you can generate new type of HTTP request telegrams, also WebSocket message telegrams, and DNS record telegrams. With using these three buttons in the toolbar, as you see, you can generate that new kind of telegrams: HTTP, WebSocket, and MDNS. Also, you can access to the all new features of EITT 4.4 by using help menu and then new features. Okay, so let's talk about the certification test setup. In the left side, there is an EITT 4.4. It's connected to KNX Twisted Pair bus via KNX USB interface. For API server, there are different options. This API server can be run on Raspberry Pi or can run on separate Linux PC, or as in my case, this proof of concept can also run in a virtual machine on the same PC with EITT 4.4. API server is connected to bus via KNX IP interface, and all communication between EITT and API server is IP based. In the final part, I want to explain all test setups. First, we will start with the configuration of the test template datasheet. This will be done according to the ETS test project. Then I will show how to generate test sequences via these templates. Then we will do some small settings in EITT which are related with the point API, which related with the API server. And then finally, I will show how to run the test and how we are going to check the results. Before starting in EITT 4.4, first we need to create a new project. If you click this button, then new project will be created. After a new project is created, select Conformance Test from the left window. Then, from the combo box, select third-party API tests, and all test cases will be listed in the same window. After all test cases are listed, next step is configure test template datasheet. To open it, you must double-click here. Then datasheet will be open in the right side window. This datasheet have parameters which are used while generating the test sequences. As you see, there are some chapters like location, device, information, which are coming from the test specifications. And all these chapters, like name of location with children, name of location with children and parents, device name with location, must be filled related to the ETS test project. It means an ETS test project is required for testing third-party API server. As you see, this is the basic project with some locations, with one device, two functions, and some group addresses. This project includes all required semantic information, which is testing. You can create your own test project, or you can use one which will be supplied by KNX Association. For certification, there will be an ETS test project which shall be used with official test templates. Now, semantic data export is done via an ETS app called Semantic Export. Via this ETS app, project can be exported in supported format that can be used by third-party API server. In this case, this is export.ttl. After TTL file is exported, then this file must be located into the API server. And of course, you must be sure API server is running properly. The information from ETS project, all required fields must be filled. As you see, information, device, function, and data points all required different kind of information, and all this information must be filled. Also the security part, but this is important. Current proof of concept doesn't include security. Security functions are not implemented. So for that case, this part is not so important. As I said before, ETS 4.4 has a function to import and export conformance test template datasheet variables. So with using this function, you can also use pre-configured XML file, which includes all these variables. So I will share a link which includes this test ETS project, exported TTL file, and also this configuration XML file. So you can use them to prepare your own test scripts. When template datasheet is configured, then next step is creating test sequences. Right-click on the test which you want to generate, and then choose RF or TP. For HTTP test, for that kind of test, this RF or TP creates exactly same scripts, so it's not important which one is selected. And you have the test sequences. As you see here, now all test sequences are created. Of course, you can generate different test cases exactly using the same method. As you see here, location test, device test, function test, different test scripts are generated via these third-party API test templates. Before running the test scripts, we have to do one more configuration. Please open Options, then KNX IoT third-party API test settings. Then you will see the interface which is used to configure API server settings in EITT. In this case, only IP and port number is sufficient. So as I said before, security is not implemented in the current POC, so you don't need to configure the security part. And of course, you have to add an interface to connect to a bus, and just connect to bus. And now we are ready to run the script, and if you click the run button, and then this script will be run, and you can see the results in the trace buffer. If you click on a specific telegram, then you will find all telegram specific information in the left window. If you double click on the response part, a separated editor will be open, and you can see all response text in this editor. This response shows the devices in the project. For example, here you will see two devices. The first device, gateway, is automatically generated by the semantic export application. But the second device is the switching actuator, which is now currently available in the ETS test project. I also recorded a video to show all test steps in one go. I told before, first you have to be sure. I also recorded a video to show all test steps in one go. I told before, first you have to be sure your proof of concept server is running properly. You have to know IP address and port number of the server. Then, in EITT 4.4, first step is creating new project file, then following conformance test tab, and then double click on third-party API tests, and conformance test datasheet will be shown. Normally, this datasheet will be empty, and you can fill this datasheet related to ETS project file, or you can just import this JSON file, which is pre-configured, and all related files will be filled automatically. After filling this datasheet, next step is creating a test sequences. For this case, I will only generate one test script which is related with device test. So I will disable unused part, and also I will disable security related tests. As we talked before, it's not supported by current proof of concept. Then just right click and choose TP and RF, and our test sequence is now ready. Before running the test sequence, we have to configure also proof of concept servers, IP address, and port numbers. As you see, IP address is not correct. We have to write the correct IP address, but port number is okay, and we don't need to configure the security part. Also, we need to add an interface to connect to twisted pair line, and then connect to bus, and when connection is established, then we can run the test scripts. After you run the script, all results will be shown in the trace buffer. In the trace buffer, if you click one specific telegram, in the left window you will get all telegram related information. Also, the response will be shown in the response part. If you double click on this response part, then a separate editor will open, and you will see all response text in one editor. For more information, you can contact me by email. Thank you so much for listening.